Hi, chemistry students. Mrs. Carlin here. I would like to spend the next couple of minutes going over with you how you name compounds known as acids and bases. And I'm sure you've heard these terms before, but let's first start by chatting about what exactly is an acid and what exactly is a base. So, for our purposes in 10th grade, an acid is an ionic compound in which the cation is hydrogen, right? H plus. Boom. H plus. A base is also an ionic compound, um, but instead of the cation being hydrogen, like in acids, the anion is hydroxide, is OH minus. Now, I'm sure when you took like middle school science and biology, you talked a little bit about acids and the pH scale. We're not going to spend a lot of time in 10th grade chemistry on acid-base chemistry. If you choose to take AP Chem, you'll do a whole lot. But briefly, if your solution has a whole lot of acid in it, or H plus, right, you're going to be on the low end of the pH scale. And if your solution has a whole lot of base or hydroxide ion, your solution is going to be on the high end of the pH scale. When the concentration of hydrogen ions is the same as the concentration of hydroxide ions, that's when you get a neutral solution or a pH of 7. We aren't going to study in depth, like I said, the chemistry behind acids and bases, but we are going to encounter them occasionally over the course of the rest of the semester. So you do need to be able to go back and forth between names and formulas of acids and bases. Naming acids is a little bit trickier than naming bases, so that's where I would like to start. First off, you will see this diagram on the back of your kudos form. And this is just one of those things that you're going to have to memorize, okay? So if we take a look at, there's 3 different rules. And what you do is you analyze the name of the anion. So for instance, if the name of the anion ends in "ide," which usually means it's monatomic and it just comes right from the periodic table, like chloride, when it has hydrogen as the cation, this is how we come up with the name of that acid. We put the prefix hydro, then you add the base of the anion name, and then you add the suffix ic acid. So an acid that has anion chloride becomes hydrochloric acid. So that's monatomic. If you have an acid that has a polyatomic anion that ends in "ate," you name it similarly, but you don't use the prefix hydro. So for instance, if you have an acid where chlorate, ClO3 minus, is the anion, that acid is chloric acid, HClO3. The other kind of acid name that you're going to encounter are ones where the polyatomic ion, the name of it, and anion, I should say, might end in "ite," something like chlorite. In those instances, you add the suffix "ose acid" to get the name of the acid. So if the anion in the acid is chlorite, the name becomes chlorous acid. So let's look at a couple examples, okay? So if I have the acid HNO2, the first thing I want to figure out is the name of the anion. So I look up NO2 on my ion sheet, my common ion table, right? And I find out that this is nitrite. So I go back to my rules. Nitrite ends in "ite." I add the suffix "ose acid" to the base or the root of the anion name. So this becomes nitrous. Ooh, that's not good. There we go. Nitrous acid. Okay. And you might have heard of that acid. Next example, okay, hydrogen is the cation. That's what makes this an acid. And then the anion is C2H3O2. Clearly polyatomic. I look at my common ion table and I find out that this is acetate. So acetate ends in ate. Boom, I add ic acid to the root, the name of the anion. And this becomes acetic acid. Last acid example. So if I look at my anion, that looks monatomic to me, right? That just comes from the periodic table, right? That is sulfide, okay? Ends in ide, right? I add the prefix hydro and then the suffix ic acid to the root of the anion name, right? And this becomes hydro. So sulfur is weird. We usually keep the UR, hydrosulfuric acid. And then actually we kind of keep those together, hydrosulfuric acid. Okay, and this is something that just requires some practice. Naming bases is a whole lot easier than naming acids. You name them exactly the same way as you would name any other ionic compound. There's no special rules actually for it. So BaOH2 becomes barium hydroxide. NaOH becomes sodium. They're seeing my great typing skills. Hydroxide. And then KOH becomes potassium, you guessed it, hydroxide. We'll do some practice with this in class on Thursday. Thanks, everybody.